Simplifying radicals. After watching this video, I will be able to simplify radical expressions by using the product property of square roots. So first we have to identify what is a radical. So we've seen this little check mark looking thing, and that is known as a radical. And that would be the radical symbol. And it has an index, meaning a number that kind of determines what kind of root we are taking. So if there is a number, a small little 3 on top of the radical symbol, this means we're taking the cubed root. If there is no no number, then it is implied that the index is 2. So if you were just to see radical 4, this means that the index is 2. It is not written. And we can say this is radical 4 or the square root of 4. A radical can have a coefficient just like we have coefficients in front of variables. And the number inside of the radical symbol is known as the radicand. Whatever your radical equals after we do the actual simplification process, that is known as the root. So let's just say that in this case it equals the letter B. This is known as the root, which is why we are able to say the square root of 4, because that 2 means square, and then our answer would be root. It is the root of the number. So a very important concept when we're trying to find roots is it kind of just disappears. So the little radical symbol will disappear after the actual process. And it's the opposite of taking something to a power. So if we have 2 to the second power, that means taking 2 and multiplying it by itself 2 times. So 2 times 2 is 4. This means that the square root of 4 would equal 2. They are opposites of each other. So we can find the square root or whatever the radical is using a calculator. And depending on what we see in the calculator would determine how we would simplify our expressions. So for example, let's look at what happens when we take the square root of 100. I can go to any scientific calculator and I can find the little radical symbol, and I would pick the one that doesn't have the n, because the one that doesn't have the n is talking about square roots. And I would put 100. Enter. And my answer is 10. So I would not need to simplify. A very important part, though, is notice that my answer is just 10. The radical symbol has disappeared. A very common mistake is to leave your answer with the radical symbol. This does not mean the same thing. If I were to put this into my calculator, I would not get the same number of 10. I would get a way smaller number. So this would be incorrect. The square root of 100 is 10, and that makes sense because 10 to the square root is equal to 100, which takes me back to my radicand. Now let's check the square root of 150. Returning to my calculator, I put the square root symbol, and I would put 150. Notice that in this case, I do not get a nice whole number. I get a very large decimal. And this would be the decimal equivalent of the radical. However, because of the very large decimal, I would need to round my answer. So this would give me a rounded answer, whereas the radical is exact. So this would be an exact answer because of the radical, and this large decimal is an approximation. And the reason that's important is because if we want an exact answer, we would need to give it in radical form. And that's why we need to simplify radicals, because sometimes we will not get nice whole numbers. We need to simplify this 150 into smaller numbers, but still in radical form so that it is exact. Okay, so looking at trying to simplify radicals require us to know what are perfect squares. And perfect squares are just nice whole numbers that when we try and find the root, I get a nice whole number. So the square root of 1 gives me a nice whole number. The square root of 4, square root of 9, square root of 16. These are nice whole numbers that I get. Any number in between the 1, 4, 9, 16, etc. would not give me whole numbers. It would give me decimals, and I would need to simplify those. And we can kind of remember this list. These numbers come up pretty often, so you might as well just recall. And the way we get these numbers is by taking 1, 2, 3, 4, 5, 6, 7, etc., going all the way down and squaring them. Okay, so we also have the product property of square roots, which just means that we can basically take anything in a square root and split it up. So if we had the square root of 36, I know that 4 times 9 is equal to 36. So this is the same thing as saying 4 times 9. And this is also the same thing as saying 4 times 9. So we can basically just split them up if it's all inside the same square root or the same radical. So this would be okay because this is all square roots. I cannot say that 4 and then the cube root of 9, and I can't combine these because these would not be the same radicals. One is a square root, one is a cube root. So as long as they're the same type of radical, meaning the same index, then you can split them up if you need to. And we're going to need to do that in the following video.